In this session, what we are going to do is we'll try to understand ratio, proportion, and variation concepts completely. See, from CAT exam point of view, this is very important. Okay, so you will get direct questions as well as application-based questions, and mostly application-based. And when it comes to XLRI, Snap, etc., again you will get a lot of questions from this area. Okay, so very important area. Ratio, proportion, and variation. So variation is also important because the application of this you can get in speed, distance, time and work, etc. Okay, so basically inverse proportionality related questions, right? For the product constancy rule that we have seen, that's what we are going to discuss under variation, but we'll try to understand ratio, proportion in detail before that. Okay, now this topic is important for SSC also, this is important for IBPS also, any bank PO exam, etc. So what is ratio, proportion? See, it's actually a fraction. It's basically used for comparison, right? See, when I say x is to y or a is to b, or I can write it as x by y or a by b, etc. Okay, so this is actually a ratio. And why we use this? Basically to compare. Like 3 oranges and 5 apples, we can write like this. Okay, so basically for comparison. Now this also can be written or understood as percentage also. So if you can write it as fraction, you can understand it as percentage. See, if you write it as like 4 by 5, this is nothing but 80%, right? So 4 by 5 means it's actually 8 by 10 if you want to. So if it is 8 by 10 means it is 80 by 100. Now what is percentage? Percentage means the denominator need to be 100. So if the denominator is 100, like here, this you can write as 80%. Okay, so I hope this is clear for you. Now what is, if you have 2 by 4, this is a fraction, this is a ratio, so this is nothing but 50%, right? 2 by 4 is nothing but 0.5. Okay, so 0.5 because this is 1 by 2. 1 by 2 is 0.5 or 50%. So the point is ratio is used for comparison. Now ratio can also be understood as percentage. So if you need to represent 2 by 4 as percentage, just multiply it with 100, right? So this becomes 25, 25 into 2, that is 50. So when you multiply with 100, you can convert it into percentage. Now ratio can also be understood as decimal values. That's what we have seen here, right? 2 by 4 is nothing but 1 by 2, 1 by 2 is nothing but 0.5. Now if I say, now how to find the percentage value? See, let's suppose you have 1 by 9. Okay, so 1 by 9. Now how to convert this into percentage? Just multiply by 100. So this is nothing but 100 by 9, right? Now this we know 100 by 3 is 33.3. So 100 by 9 means divide again by 3, so you'll get 11.11. So this is what the percentage equivalent of this ratio, right? So 1 by 9, if you need to convert into percentage, 11.11. Now if you need to convert this as decimal, basically you need to shift 2 points, right? So you shift 2 places to the left, then it becomes 0.1111. That's it. Why? Because this 11.11 is in percentage, means divided by 100. So when you divide by 100, shift 2 places to the left. Okay, so it's like if you have a percentage which is given 83.87. okay, so the ratio is given in percentage. So if you need to express this in decimal, you just shift 2 places to the left, so it's nothing but 0.8387. 0.8387. So a ratio will have will be like this: a by b or x by y, right? Now for example, it can be 4 by 5 like we have seen, and the decimal expansion means 0.8 and the percentage equivalent means 80, right? So how you convert this to percentage? 4 by 5 into 100, so you get 80. How you make it to decimal? Shift 2 places to the left, so it becomes 0.8, right? So that's what we have seen. Now see the numbers involved in this ratio, 4 and 5. And these are called the terms of the ratio. Okay, now let's understand the words, okay, which are involved. So you will see these words. So terms of the ratio means the numbers which are involved, 4 and 5. So here a and b. Now the numerator in the ratio is called antecedent, okay, antecedent, and the denominator is called consequent. Okay, so consequent. So antecedent and consequent. Antecedent, here it is, here if you see a, consequent is b. So consequent is the denominator, antecedent is the numerator. So we have understood that ratio is basically used for comparison and it is expressed as fraction. Okay, see, when you say ratio and fraction, both are actually same. When you're writing, then also it is same, but when you use it, it may be different, right? So that's the only difference. The way you use it is different as ratio and fraction. But representation, conversion to percentage, conversion to decimal, everything is same. Now, let's try to understand some of the properties of ratio, because you will be getting questions in aptitude exam based on the properties only, and if you know these properties, you can solve the question faster. So let me start off with very simple and basic properties, and you might be knowing it already, but next 5 minutes, very simple area. So you may think that I'm wasting time, yeah, but there is no other way, because I'm coming to the best part of it. Okay, so let me start off with very simple points. Now you have a ratio A by B. Okay, this is a ratio A by B. Now if you multiply the numerator and denominator with the same number, let's say P. Okay, so let's say P, so AP by BP. Okay, now this AP by BP will be equal to A divided by B. Very simple, because this is obvious, because P and P is getting cancelled out, you know this, right? So it's like 4 by 5 ratio. Okay, now 4 if you multiply with 2 and 5 if you multiply with 2, what you get is 8 by 10. So 4 by 5 and 8 by 10, both are actually same. That's the property. Okay, and same way the reverse, it's like you have a ratio A by B. Now if you divide A with a number and if you divide B also with the same number, then the ratio will be same. It's like you divide A by M, okay, then you divide B by M, so these two will be equal. Okay, because this is getting cancelled out anyway. So if you see here, let's suppose you have a ratio 4 by 6. Okay, now you divide numerator and denominator with 2. Okay, so 4 by 2 and 6 by 2. What you get is 2 by 3. So the point which I need to tell you is these two are actually same. Ratio is same. Okay, so 4 by 6 is nothing but 2 by 3 itself. So when you divide with the same number in the numerator and the denominator, the ratio remains unchanged. And next is again very simple but important one. You may need to use it in some application questions. Okay, see, that is denominator equation method. You may be asked to compare two ratio and they will ask you which one is larger. Okay, so in that case what you can do is, the best way is to equate or make the denominator same and see the numerator, and in which ratio numerator is high, that ratio will be the largest one or the greater one. Okay, so for example, if you need to compare this two ratio, 8 by 3 and 11 by 4. Let's suppose you need to compare this. You got this question, which one among this is highest one? Okay, so if you can convert this into percentage, it's fine. Okay, just multiply by 100 here and here, and then you will get the percentage equivalent, so that you can understand. But without doing that, what you can do is, okay, see, when you are converting into percentage means effectively what you are doing is you are converting the denominator in both cases 100. There also you are making into the common denominator, right? So rather than doing that, what we can do here is either you make this denominator as 3, you make 4 as 3 by dividing 4 by the required value, then make the necessary change in the numerator, or you can convert this 3 as 4. Okay, then you'll have to multiply 3 with something else so that you'll get it as 4. Then what is the advantage is both denominator will be same, and see what is the numerator. Okay, so how to make this 3 as 4? 3 into 1.33. So what is the factor of multiplication between 3 and 4? 4 by 3 is basically 1.33. Okay, so when you multiply this denominator with 1.33, you can make it as 4. Then both the denominators are same. So obviously numerator also you need to multiply with the same. And I told you from the first property, this ratio remains unchanged because you are multiplying the numerator and the denominator with the same value. So what is actually happening here, when you multiply 8 with 1.33, you will get it as 10.66 and the denominator will become 4. And this is the same 11 by 4. So if you look here, denominators are same. Now you see where the numerator is the larger, so here it is larger. So which ratio is greater? This one, this 8 by 3 is less than 11 by 4. Okay, so this is one of the method. Otherwise, what we generally do is, you just multiply this into 100, this also with 100. So effectively you are converting this to percentage and this also to percentage. Then you see where you get the higher percentage. Now, why this method is useful or why this is working is basically because, see, the value of the ratio is having a direct relationship with the numerator and an inverse relationship with the denominator. So if you connect it to what we have learned in the previous sessions, you can solve it faster. So there is no point in discussing the one which we have already discussed. So I am skipping this, the product constancy rule. Okay, you can apply here and you can understand it faster. And in fact, I have solved the same example there also. Okay, so now next property, let's suppose you have two ratios like A by B and C by D. Okay, so this is one ratio, this is another ratio. So this is a fraction, this is also a fraction, right? Now the property is the ratio of these two fractions, okay, can be expressed as integral value or integers. How? Just multiply this. This become AD and CB. So this has to be an integral value or integer, right? So the ratio of two fractions can be expressed as integers, two integers. Okay. Now, so if this is a property in certain cases, now this is very important. This point that I am going to discuss is now very important because that you can use in many questions to eliminate answer choices. See, in this fraction, if one of them is a third or if one of them is irrational, like let's suppose root 3, root 2, pi, etc. Okay. So if one of them is irrational, like let's take an example, root 3 by root 2. Okay, so here 2 are irrational or 2 are thirds. Okay, so here it can never be expressed as integers. It can never be expressed as integers. So the moment you see like root 2 in your question, in your answer choice also you will have a root 2. Unless there is a possibility of getting it cancelled. So you are looking for an answer choice where root 2 is there. Otherwise, there should be a possibility of getting this root 2 cancelled. Same is the case with root 3, pi, etc. So your answer choice should contain this one. So based on this property, you can eliminate many choices. Why? The reason is, if you want to remove this root 2, there is no other way except either multiplying with root 2 or dividing with root 2. So in your process of calculation, this should be there. Otherwise, there is no possibility of removing root 2. So from the answer choice, you can remove any options which do not have root 2. Okay. So now if you want an example, let's take what is the area of equilateral triangle? So that is root 3 by 4 a square, right? Root 3 by 4 a square, or the height, if the question is root 3 by 2a. So root 3 by 4 a square. Now when you solve this, okay, you should get root 3 in your option. You should get root 3 in your option. So what is the only way in which you should not get root 3 in your option? The side of the equilateral triangle should be 4th root of 3. If you get one side, if you get the side in terms of 4th root of 3, when you take a square, that becomes square root. Okay, then there is a possibility of getting this removed because square root of 3 into root of 3 you may get. Then it can be removed. So in your side, there is no possibility of getting a 4th root of 3. In your option, if you don't find root 3, eliminate that option. Because your answer option, the correct answer should contain root 3. That's the idea. Okay. So I hope this you understood. So this is a very, very important property. Now, another common thing is if you multiply two ratio like A by B and C by D. These two fractions, if you multiply, there's common sense and you know this already, AC by BD. Just multiply the numerator, multiply the denominator. Okay. So this is what you get when you multiply two fractions or two ratios. Now, when you multiply A by B, this ratio with itself, that means you can say it as this ratio is compounded. Okay. So when this ratio is compounded with itself, okay, so A by B is compounded with itself, what will happen? A square by B square. Application of the previous rule, right? So what you get is A square by B square. So what we call this as duplicate ratio. Okay, this word need to be understood. So duplicate ratio. Now if it is 3 times, that is A cube by B cube, you call it as triplicate ratio. Okay, then it is triplicate ratio. Only for the purpose of understanding the words I am discussing. Otherwise, this property is known to you. Sometimes they will give you in your question triplicate ratio will be given. So you need to understand that was compounded itself 3 times. That's what triplicate ratio. What about half? That is A raised to 1 by 2 and B raised to 1 by 2, or A raised to 0.5 and B raised to 0.5. What we call this a sub-duplicate ratio. Okay, so this is duplicate ratio, triplicate ratio, now sub-duplicate ratio. So these 3 words need to be known to you. Now another property is, see, if you have some unequal fractions, like some ratios, okay, all are not equal. So like a1 by b1, comma a2 by b2, comma a3 by b3, etc., etc., an by bn, and these are unequal fractions, okay. Then the ratio, this a1 plus a2 plus a3, you are adding the numerator, okay, up to an divided by b1 plus b2 plus b3 up to bn. Now this will lie between the lowest among this ratio, okay, lowest among this ratio to the highest among this ratio. So the sum of numerators and sum of denominators, if you take, and if you take the ratio between sum of numerator and denominator, that will lie between the lowest among this and the highest among this. So this is very useful when you solve questions. We'll come up with the examples in the next session. Okay. So here I'm just discussing the concept. So I'm not discussing question here. So let's understand the concept in the first session, and in the second session is dedicated for the solutions of questions. Okay. So what I'll do is in the next session, level 1 difficulty and level 2 difficulty in the third session. Like that we'll proceed. Now another is if you have three unknowns, like you have two equations like a1x plus b1y plus c1z is equal to 0, equation 1. So basically you have three variables or three unknowns, okay. Similarly a2x plus b2y plus c2z is equal to 0. So this is equation 1, this is equation 2. Here if you observe, you have you have unknown here x, y and z. So three unknown, okay, and two equations. Now the common sense is, see, if you have three unknowns and only two equations, you cannot solve this question. Without getting the third equation, you cannot solve this question, okay. But you can understand the ratio. See, even if the third equation is not available, we can find the proportion of x is to y is to z, okay. See, it's like x will be b1c2 minus b2c1, okay. Y will be c1a2 minus c2a1. Z will be a1b2 minus a2b1. Okay, you should write in this order, and you can, now if you want a shortcut or a method to remember this is what we have seen in schools, right? If you remember, we have discussed this in 9th or 10th standard. See, you can write like this, b1, b2, okay, and c1, c2, then you write a1, a2, then b1, b2, okay. So this 4 is what I'm going to use for x, this 4 is what I'm going to use for y, this 4 is what I'm going to use for z. Now how will you proceed is actually like this. You should start from here, come like this, okay. So you get b1 c2, then you go like this, so you get b2 c1, so you got x, okay. Now you proceed like this, you continue like this, so you get c1 a2, then go like this, so c2 a1. And now all are minus, so you don't want to have a confusion. All are minus. Now from here, after you stopping, you come like this, that is a1 b2, and then you go like this, a2 b1. So if you remember, if you can keep this in mind, this is how we used to remember in our 10th standard, okay. So I am just discussing what you have learned in our 10th standard, but all those things are not required. I just told you, see, this is a possibility. In CAT exams, you can get questions like this. See, you get two equations and three unknowns. I told you that you cannot find x, y, z by only two equations. You need a third equation, but still you can find the proportion or the ratio of x, y, z by two equations. And this is how you do that. So I hope this is clear for you. Now, another very, very important point. See, this is a very important point. You can expect questions based on this property. See, let's suppose you have a ratio a by b which is greater than 1. Okay, see, a by b which is greater than 1. Now we call this as ratio of greater inequality, okay. So because this is greater, the ratio is greater than 1, so ratio of greater inequality. And let's suppose k is a positive integer, okay, or positive number. K is a positive number. Now let's take the situation, a plus k divided by b plus k, okay. A plus k divided by b plus k will be less than a by b. So what we said is, this ratio is greater than 1, okay. Then any positive number you add to a and the same positive number you add to b, that's what we have done. That will be less than the ratio. So remember, you adding a positive number, but still you are getting a lesser number than the ratio. This value is lesser even though you are adding a positive value, okay. Now if you are subtracting, the reason I tell you, see, if this is the case, a minus k divided by b minus k, if you are subtracting, this value will be greater than a by b. Okay, so what is the case? A by B is greater than 1, the ratio is greater than, whatever, forget about everything. The given ratio is greater than 1 and you add any positive number to the numerator and the denominator, then this ratio will be always less than the given ratio. Now, if you subtract the positive number from the numerator and the denominator, but the number has to be the same in numerator and denominator, then that will be always greater than the given ratio. Now what you can do is the opposite. It's like A by B can be less than 1. Okay. So what is the next possibility? It's like A by B will be less than 1. Okay. See, A by B less than 1. Now again the same situation. K is a positive integer. Okay. K is a positive number. Now let's see if you add like this A plus K and divided by B plus K. Now this will be, here it is less than A by B. So here it will be greater than A by B. When it is greater, this is greater because this A by B ratio is less than 1. And now the opposite, like A minus K divided by B minus K, now you know this, right, will be less than A by B. So remember this, very important. Okay, so this one is very important. See, A by B greater than 1, you are adding a positive number in the numerator and denominator, that ratio will be less than 1. You are subtracting a number in the numerator and denominator, that ratio will be greater than the ratio. Now the opposite is A by B less than 1. You are adding a positive number to the numerator and denominator, the ratio will be greater than the ratio. And if you are subtracting the positive number from the numerator and denominator, the ratio A by B will be greater than this ratio. I hope this is clear. A lot of application you will see, and in fact we will discuss applications of this. Okay. Now let's suppose you have 5 by 8, okay, or 50 by 80. Now you have another ratio that is 55 by 88. Okay, see this and this will be same. The reason why it is same is basically because this is 50 by 80 and what is 55? That is 50 plus 10% of 50 and divided by 80 plus 10% of 80, right? So here, now what is 10% of 50? That is 5, okay, and what is 10% of 80? That is 8. Now here if you observe, 50 by 80 is equal to 5 by 8. So if you consider this ratio, that is also 5 by 8. Okay, so what you added is actually same as that of the given ratio. So if you added 5 by 8, the ratio remain unchanged. If you add 10 by 16, that is 20% of both, then also ratio remain unchanged. So this is how you can keep the ratio similar by adding something. Okay, you are adding the same proportion. So if you want to generalize, you have a ratio A by B, okay, and you're writing it as A plus C by B plus D. So this will be equal if C by D is equal to A by B. And in our case, C by D was 5 by 8 and A by B was 50 by 80 and both are equal. So this ratio will be equal. So the last two ratios that we have discussed, the properties that we have discussed, is very important. Okay. Now I hope all of you understood this completely.